Whitelist all the things. That is roughly the idea behind zero trust access, and I'll decide what you should have access to after I've observed your good behavior for a while, and if you start doing something weird, hey, we're just not going to allow that. Systems like that, they're complicated, and any network engineer who's tried to deliver just microsegmentation can tell you that. Plus, nobody wants to be the human getting the ticket where an executive is complaining because they can't get to the thing, because obviously no one wants that, right? So perhaps you're thinking, I'm going to nope right out of that ZTA stuff. It's too hard. It can't possibly work. And we're a multi-vendor security shop anyway. Well, our sponsor today is Fortinet, and they are here to tell you why you need an attitude adjustment, an adjustment that maybe, just maybe, gets done with machine learning. Our guest today is Fortinet's John Maddison, and we're going to discuss edges, secure access to all those many edges, and why it's table stakes to integrate multi-vendor security tools these days. John, welcome to Heavy Networking. And so we got to get into edges, because if people heard me say edge, they're thinking, oh, edge computing, I don't care about edge computing, and then they're tuning out. But that's actually not what we're talking about, John. So could you explain for the purposes of this conversation what we mean by edge?
Yes, edge. And edge, maybe 5 years ago, some people referred to as the perimeter. But edge today, edges are appearing all over the network. It used to be very focused on the data center edge. Now with SD-WAN, we've got the WAN edge. With cloud applications, we've got the cloud edge. You've got the LAN edge. With manufacturing, you've got the OT edge, IoT edge, remote worker, work from home edge, home edge. So edges are appearing everywhere, and those edges absolutely need to be secured.
So I used to think of edges like that as really separate problem spaces. But I think the point that you guys want to make is that engineers need to think of all of these multiple edges. Yeah, they're multiple edges, multiple places that they are, but they really have a common problem. Is that a fair way to put it?
Yeah, because they've got different trust levels either side. So if you've got trust level of, say, 1 on this side, trust level of -5 on this side, you need to put a certain amount of security. And so we feel that security everywhere, across every edge, is essential.
I just want to ask a question here. There's so many niches in the edge as a marketplace, and usually the fact that edges, that niche markets exist, is usually means there's some sort of niche there that's waiting to be filled. But I think what you're indirectly saying is that all of these edges are actually got the same universal problem.
Yes. They've all got different trust levels either side. And when you've got that, I mean, the WAN edge is the perfect one. Everyone introduced SD-WAN. They suddenly realized, oh, wait a minute, I've now got direct internet connections. I've got a different trust level. So I need to introduce that security. Having consistent security, or the ability to deploy it at every edge, is very important.
You say different trust levels either side. You've said that a few different times now, and you like gave numbers at some point, like -5 and +1. What do you actually mean by that?
What I mean is that you've got on one side you've got a trust level which you understand because maybe it's on the network. On the other side, you're interfacing with something you don't know, the internet, or even cloud. Some customers don't even trust the public cloud. So there's different trust level means you need to apply that security or that barrier. And it could be simple firewalling, or it could be simple, or it could be more complex next-gen firewall you apply.
Okay, that's what I thought you were getting at, but that's actually counterintuitive in a modern day security conversation, because so often that conversation is, we don't trust anybody. We don't trust you on the inside. We don't trust you on the outside. You're probably infected with malware, and we just don't trust anyone, therefore. But you're saying there is some amount of trust that you can have depending on context.
Depending on the edge. So I would say for users and devices, you should apply the zero trust. So but if you're between the cloud and the network, maybe there's a bit more trust in there.
So what you're alluding to there is a LAN edge assumes that you're inside of a corporate building. And so the trust level there would be different to a remote worker edge, because Correct. You might be working from a coffee shop or some shared environment in a co-working space. And therefore you have a different level of assumed trust or presumed trust.
Absolutely correct.
To be fair, this doesn't actually sound all that different from BYOD, which was everything we were talking about 5, 6, 10 years ago, even VPN, accessing SaaS resources and so on. I identify what the problem is. I evaluate tools that address whatever that problem is. And then I've got security. So what is different here, John?
Well, the industry's very good at its acronym soup. We like new acronyms. I think SASE is the latest one, zero trust there. It is the same problem, but things have evolved. We have more cloud today. We have faster networks. We have 5G coming. We have a lot more devices that are IP enabled in factories. And so it is different. It's actually expanded the attack surface in some way. The acronyms have changed a bit, but the problem's expanded.
So talk to me for a minute about BYOD then. I want to hear that one specifically, because for so long the mindset was, no, you can't bring your own device. All right, you can bring your own device, but we're going to put it in jail and you can only do a thing and that's all you can do with it, et cetera. There are all these different paradigms that seem to be a big pain in the butt to implement in real life. A lot of companies have sprung up around it though. I mean, is that still the kind of thinking, or do you look at a BYOD scenario differently now?
It's slightly different. I mean, I think what happened was the MDM companies sprouted up and they ended up being more IT operations than security. I think the security on the devices that took care of that themselves, so it wasn't quite as bad. So I think the problem wasn't as bad as people said, but you still need to manage those devices in some way from an operational perspective.
Yeah, now you bring up the problem of tools. You mentioned the MDM folks, and a lot of us bought into a lot of different suites of security tools, each solving a niche problem. And so now I got 50 of them that I got to keep online for whatever reason.
At least.
Yeah. So how do I fix that in the modern day?
Well, we're definitely seeing customers start to think about more of a consolidation and convergence, running multiple applications on the same platform or solution. You know, when you think about things like IPS, there's a lot of point solutions that came. At that point in time, they were so-called best of breed, sorting out a certain problem. I think a lot of those are starting to consolidate. Things like they're becoming features, like SD-WAN, like SSL inspection, like IPS. They're just kind of features. And what you need to do is converge them on a single platform and free up resources, both money and people, to work on other things.
I think it's also interesting that we're seeing a lot of these tools that were once separate and you had to buy them separately and then build them together. We're also seeing companies like Fortinet, which was once a firewall company, then a firewall manager, then a VPN, and then a VPN manager, and now it's everything folded into one. It's not a separate product. It's not even a separate purchase in many cases. This whole convergence process is rather much broader, I think. Is that reasonable?
Yeah, so I think what's happened is when speaking to customers, they realize they've just got too many point solutions. And the issue is they can't build automation across. I mean, the industry is bad in a way because we don't work that well together. We don't share information. But I think they want platforms, but they don't want to go from 30 vendors to one vendor. They want to go from maybe 30 vendors to maybe 10 platforms. And those platforms need to work together and interoperate.
I think that interoperability will be an important discussion more and more in the future.
Yep.
I call it the East-West SDN, or the SDN Federation, where my Fortinet solution needs to talk to other vendors sideways. And that's probably the point where most engineers going forward will spend their time integrating via code, low code, no code, or full on, full code solutions to do that sideways integration.
Yeah, because we just haven't got where we need to get in terms of automation. You just need to build that automation to stop things occurring. But as we go forward, you need to build that automation because the digital experience is going to be very important.
One of the thoughts I have around consolidation, John, is regarding enforcement points. With my point solutions going back in the day, that was kind of part of what you were buying into, is where you were actually doing the enforcement, whether that was on a specific device at a choke point in the network or at the network edge or actually on an endpoint itself. So what does that look like now if I begin consolidating? Do I have agents in the endpoints? Do I have all of the enforcement happening in the network infrastructure? I got to tell you that I personally am done. I am done managing a bunch of firewalls, and I think Satan himself invented agents. So I'm hoping for something better. I'm just curious to get your take on it.
Well, if you go back in time, the reason we have a lot of products was the different threat vectors, as you said. Stop email, file, network. And so we built across the attack surface. Then over the last 5 or 6 years, we built depth. Gone from protection to detection and response. And you have this kind of matrix of products. I still think there'll always be an endpoint marketplace. There'll be a network. There'll be a cloud and application security. They may adapt, but they'll consolidate and converge to make it easier. So the issue with endpoint is I've got 10 endpoints. Well, that's really hard to manage, and it slows my endpoint down. So it just needs to be made easier and simpler and more automated for customers.
What about, I think one of the other things too is this is where the vendors have something to add as well. In the past, vendors made products that had features, and we've sort of reached a stage in the market where, more or less everybody's got roughly the same feature set. And what we turn to vendors for going forward, and this is a bit of a future thing, is that you're doing a lot of the work for me. So your software platforms are doing the VPN setup and the configuration. The software starts to do the inspection automatically. We have threat detection feeds. So instead of me configuring a threat detection engine and monitoring the IDS rule set, it's become automated as part of a standard tool set from a vendor. I may have to do some tuning, but I don't have to do the whole thing. That is really the transition around platforms that I'm seeing. Would you agree with that broad thrust?
Yeah, it comes back to the automation. I'll give you an example we can do today. If we find an endpoint's got a vulnerability, I can tell the SD-WAN engine, don't give access to the data center or cloud. Or if I discover a device, an IoT device, I have no clue what it is and what it's doing, I can tell the access point, take it off. So once you build those automation things in place, which used to be done manually, again, you free up time to do other things. But most importantly, your speed of action is incredibly faster than manual.
Yeah. Well, I think I'm becoming, I want to rely on vendors to do dumb things or simple things or everyday things.
Yes.
So that, and this is where these orchestration engines, these platforms are so valuable, is I want to say anybody who's in this profile group that successfully authenticates can have a VPN connection. And that should be it. That's really what you want to achieve. And tools like the Fortinet platform do all that for me in one basic click, sort of.
Yeah, so I think we talked about all the point products, which is an issue, but I think the bigger problem is all the multiple orchestration systems. You've got orchestration systems in the cloud, and the data center, and the WAN, and the access, and the identity. People don't realize they've probably got 10 major platform orchestration systems that have probably no chance of talking to each other. AWS doesn't want to talk to Google, or doesn't want to talk to VMware, et cetera. And so we don't want to be the orchestration system, but we need to talk to those individual orchestration systems to understand where the infrastructure is, and then adapt the security posture.
Okay, wait a minute, John, because I thought where you were taking us was, and because you kept saying automation, we need to be able to automate a lot of this stuff. You said that several times. So I'm thinking, okay, that usually means I got to get into a vendor-specific ecosystem where all the parts play nicely together and there's a cohesive API and an orchestrator like you just mentioned. But then you're saying, wait a minute, so but not. We've got multiple vendors that we're dealing with, and we need all of those to work together. That's counterintuitive to me. What are you getting at?
Yeah, because they just don't like working together. Those big orchestration platforms, they're not friends. So what we do is we build what we call connectors into them. And when we build a connector, that means we've got an automated object. So we can automate the objects inside there. All we're trying to do is interrogate and find out where the sessions are running, or where the WAN links are going, or who's got the identity. And a very simple one is Active Directory in Microsoft or in Azure. So once we connect into there, we can bring that information out and apply it to the security posture. So we provide the automation layer or the platform by integrating into the different orchestration systems across the infrastructure.
Okay, so you're not saying I got to throw out all my security stuff and just go all in on Fortinet. You're saying you've got some stuff, we're going to do some consolidation, and Fortinet would become what? How is it positioned in my security architecture? As like an orchestrator of orchestrators sort of thing, or
no, it's a cybersecurity platform that uses integration into the orchestration systems to find out what it needs to find out. Like the very simple one is just the Active Directory, where I know who's a user, who's not a user, and I can apply that as a policy. So we will interact with the different orchestration systems to find out what's relevant for that part of the network from a security perspective. But I think what customers are doing today is they're saying, again, I'm going to choose 10 strategic platforms. It may be Microsoft, it may be Cisco, it may be Fortinet, and I want to make sure that those platforms and those orchestration systems work together to give me the automation.
Okay, so they work together to give the automation. You're able to query them, get lots of information, publicly accessible APIs. You know how to gather that data and become informed then about all the objects that are on the network. Where is my enforcement happening? Is that happening at a Fortinet firewall?
Yeah, at the edges. So it'll happen at the edges, and it'll happen in the east-west, and it'll happen at the endpoint. So those are the places that it needs to happen. And again, if we're there, it could be our endpoint, it could be our firewall, it could be our WAF in the cloud. So it could be different types of enforcement depending on where it is inside the infrastructure.
Okay, so endpoints that you can control and push informed policy into, where you've built all this policy with informed metadata, you can push that into a variety of different endpoints, security points that you've got, and now does this begin to look like a cohesive zero trust policy?
Yes, because the zero trust, I think, needs to be able to look at everything coming on and off the network. Is it on the network, off the network? And then more importantly, what applications is it trying to get to? So the other, really important piece is the orchestration of the mapping of users and applications. If I know which users are mapped to which applications, I can then apply that information to my zero trust architecture. So what I'm saying is, if you've got that platform in place across endpoint, across the proxy, and then the application mapping, then you can provide some of that contextual information that gives you a true zero trust.
The glories of application inspection, it's just how far firewalls have become more valuable and useful, because 10 years ago, everything was inspected by TCP port or UDP protocol.
Right. Yeah.
And now we have every device has application inspection. So we can look at HTTPS, we can look at what URL you're going to, what certificate you're presenting, and actually classify traffic on the most amazing, like still to this day, still amazes me how far we've come in the last few years on application inspection at the edge.
But it's also enhancing that. So we can see 8,000 applications, but we can also interrogate the CMDB to understand what applications you have running. We can also interrogate the Active Directory to understand what users are there. Map all those things together, and you have an absolutely foundational component of zero trust.
When you were talking about Active Directory, so an example here, I can know that Greg, the user, is accessing this web application because I've got his Active Directory context. If I've got a web application firewall sitting in front of that app, as Greg comes through, no matter what endpoint he is coming from, I can give him access or deny him access and log what's happening. And again, that conversation about TCP ports and IP addresses and all that kind of stuff kind of goes out the window because we're thinking about it in a much different way, a dynamic way.
Thinking about it in terms of users and applications already, SD-WAN, that's why SD-WAN is here to guide to route on applications versus IP and tables and stuff like that. Already SD-WAN's overtaken enterprise IP networking gear. So the conversation is more about users and devices and applications. Applications will keep moving around. I've moved into the cloud right now. Already 50% of data is processed outside of the cloud and edge compute and things like that. So it's going to move around a lot. Users, they're all work from home right now. Are they going back to the office? Or they start traveling again? That'll change. So you've got dynamic nature of users and devices and applications. In the middle is what you create this zero trust network to provide the ability for them to access what application only they need to access.
Although users and application having security policy context, that in itself is not new. We've been able to connect firewall policy to Active Directory on a variety of platforms for kind of a long time. So if we're making this out to be quote unquote new in the context of zero trust, new marketing buzzwords that we've gone around this, what is new? Is it simply context?
A lot of it's the context. I think that's a lot of the value. Is the why are you accessing the application? Do you do this? And then are you behaving correctly? Where are you? What time is it? What applications you're accessing? That's the kind of new bit, is the context of the user and devices. The application mapping is probably already kind of there, as you say, through the application control.
Yeah, the metadata. It's not just enough to know the application. It's now the next phase, which is almost what we're discussing here. The whole purpose of what we're talking here is it's the metadata around the application. So sure, you're accessing Azure. Who's accessing it? What time of day is it? Are they permitted to do it? What part of Azure are they accessing? That metadata is the key.
But Greg, you just described metadata in a very absolute engineering-oriented way. But John, you used a subtly different word here. You said why. Why are you accessing the network and getting at this application? Why are you on or off the network at this particular time? So what is it in the metadata that can give us that kind of context, that why context, as opposed to what?
Well, that's the AI piece that comes later on. I think, the next step is more the behavior. And so you apply systems, is it the right time? Are you really a user, a human, or is this a machine trying to access on your behalf? So the behavior comes next, then the AI comes later on and as to the why.
Okay, so now you just said AI, and we do need to get into that in a bit. But I have a different kind of question.
I almost want to get a hooter out and go.
AI buzzword dropped. Yes,
drink. There it is.
Oh.
There it is.
But okay, and John, we were prepping for the show. I know that we do have an AI ML part of this conversation to have. I even teased it in the intro. But before we get there, I will say that you have alarmed me as an engineer a bit when you bring in this context and metadata stuff, in the sense that How do I troubleshoot this when it doesn't work? So back in the day, looking at a policy with IPs and port numbers, it was pretty easy to tell why the policy worked or didn't work. Maybe you had a bunch of rules to grind through, but you could ultimately figure it out. It was straightforward. Now it doesn't sound straightforward. So take me through a troubleshooting exercise. Let's say some executive can't get at some application that they're supposed to have access to. How do I fix that problem?
Why is it always the executive you give an example of?
Because they scare us the most, and they're the ones that are always the exception to the security policy.
That's probably true. I think any behavioral system, remember when IPS first came out, all sorts of false positives, and they stopped doing behavioral stuff on the endpoint. So you're getting back into that area. The question is, how can you refine the policy and can it learn? That's why I think Zero Trust has just gone in the first few steps right now. And I think as we roll out the contextual pieces, that's when you start introducing behavior, and that's when mistakes can happen. So you've got to be able to roll back things really quickly or incrementally increase the behavioral kind of component.
Oh, did you just tell me that the whole way you troubleshoot is to roll back?
Yes, I did.
Come on, man. Give me a little more than that. So from an engineering perspective, I'm anticipating that even if I am leveraging artificial intelligence to give me some dynamic sort of contextual policy, there's going to be a UI that I'm going to be able to look at. So for example, I'm anticipating I've got a log screen that's going, there's some event that's going to be in there that I can see. Executive Bob tried to access the thing and was denied, and here's why, a rule or a policy entry or something to give me some context there, some context about the context. Is there something like that?
Yeah. I was only joking.
Okay.
Well, not really.
Dude, you deadpanned that hard. It did not sound like you were joking. But okay. So take us through it. I think
it's kind of like a control panel. As you switch more things, I was half joking because as you switch more things on, then it becomes harder to know exactly. So the key is knowing if you've switched ABC on, where is A and where's B and where's C from a control point perspective. And so I think what you're going to have is the kind of a control panel that says I've switched ABC on, which gives me either this context A, context B, context C, and I've applied that. So, when I look into the system and the person can't access, it pops up and says B has blocked it. That's the issue. And so you get straight to there.
Okay, control panel, straightforward. In other words, that's the same kind of thing we've dealt with before. When a connection is denied, even though there's new fancy context and metadata around that denial event, that can still be a logged event with logic behind it that I'm going to be able to drill into and see and go from there. Now, the resolution might be rollback because the algorithm's not sufficiently mature to give access where it should and deny where it should. Is that something like that?
Yeah, and again, I think this is why customers are just rolling this out slowly because, again, the more behavior or context kind of systems you apply, the higher the risk of something kind of not working quite right. So I think right now it's simply based on some of the components around the are you on the network, off the network? Have you authenticated? Do we know what the device is? Which applications you're trying to get to? Let's apply a simple algorithm, contextual algorithm around that. Now, as you go forward into behavior, that's where it becomes a bit riskier.
So you're establishing a level of trust around that request that's coming in to access a resource because you just gave a whole bunch of criteria that can be built around that. And an authenticated user doing something that they've done in the past that all seems predictable and normal would get a pretty high, like it sounds like a trust score or something like that.
Yeah. Because you know who the user is. They're using the same device. The device has got has got security on it. That they've got rights to access the application or they've accessed this application. Those simple things improve the trust by a large margin.
So, John, being able to establish a trust score based on what we know about an endpoint and predictable behavior, that's not all that new in the security community broadly. We've had those kind of heuristics before. So what is new here? Is it the application of machine learning and then some kind of AI algorithm on top that's changing things?
Well, I still think a lot of customers are implementing some of the basic zero trust stuff that you just mentioned. So but there's a long way to go before the majority of customers have done that. But I think the next step is that behavioral component. The why are you normally doing this? Because you can still fool some of those initial things. If you get hold of credentials, you get hold of somebody's machine, it's stolen. Maybe you're lucky on guessing the application. You can still get past some of those things. Then the next thing is the behavioral piece. That will provide this extra layer of security on top.
Okay, so now we need to draw the line then between what's today and what's tomorrow, because some of what we've said is like now, and then some it says it's forward looking. So I don't know how forward looking we're talking here, but draw that line for us and tell us what's now versus what's coming.
I think now is, again, you can do user identity, authentication, multi-factors. You can understand that the machine or the device. You can make sure the security is on there. You can put enforcement points through the proxy or the firewall or cloud firewall. And I think what's happening now is people are just making sure they understand which users can access which applications. That's rolling out right now. And then as we go forward in the next 12 to 18 months, we'll start to see the initial behavioral type context applied on top of that.
12 to 18 months. Okay. Now, you said, but some customers are working with this technology today, special beta customers perhaps.
Yeah, I mean, but they've not rolled it out across a large install base because, if you get an issue. So some customers are starting to deploy it in small numbers across small parts of their environment.
What does a security policy look like when it's being driven by AI as opposed to being lovingly handcrafted by me, let's say?
That's a good question. So I think
what he's trying to do there is equivalent himself with an AI.
If only.
I just want to get the word AI in there, or was that what you saying? It's pretty subtle, I've got to say.
Yeah, it was. Yeah.
I think two things. One is that the current policies have expanded to being not just one enforcement point. So a policy would consist of endpoint plus network plus maybe application. It all comes together. When AI looks at it, and I think today, to be honest, and I'll use another buzz term, machine learning. Most systems are machine learning. They're just taking large amounts of data and applying a specific application. AI, I think, is coming forward. An example to me is, security. We've got a lot of machine learning in place right now across each threat vector. We pass a file through 1 billion good and bad files and get out a pretty good result. What I really want, though, is to look across all the threat vectors and see if there's a campaign out there in the wild that's attacking certain parts of people's networks. That's the key area, and that's much harder because you've got to take more data and apply it across a broader application. But coming back to your original question, AI is going to look not only across multiple parts of the network, but it's also going to have depth as well. So that policy is going to have like a two-dimensional, broad, horizontal, and in-depth.
In-depth meaning the number of attributes of the conversation that it is looking at. Like it's not just 5 tuple, it's 50 things.
Exactly. Across each area, it'll say, is it changing the registry on the endpoint, or is it trying to bypass the firewall through SSL, SSL hole or whatever? So it's looking across the different areas, and then it has depth in each area to apply the data.
Okay, it feels like we have a compute problem here, because to do this at scale and evaluate that many criteria over millions and billions of flows in a modern network, a very short amount of time, how am I actually pulling that off?
Well, that's the next step. That's what I'm saying. Today, it's mostly machine learning. That's got even 1 billion is not a lot to an AI engine. So you've got billions of events, and so you've got some pretty good machine learning going on right now. The AI is a whole different level of I don't want to use the word context again, but a whole different level of data, and the application's much broader, makes it much harder, and more opportunity for mistakes.
Because it'd be wrong, right? The problem with training models is that humans struggle to understand AI and how it works and why it got to the answers. And machine learning particularly, it might discover something and recognize it as a threat, but there's no way that we can prove that it's actually a threat. The machine learning in some senses is smarter than the humans because it can see things that humans can't. So,
to me, the machine learning is more about the size and the speed. I can go through, do a lot of work and process a lot of work very quickly across a big data pool, and it gives you a pretty accurate result because you've trained it to kind of do that. AI has to make some of its own decisions. That's the difference.
For the data set and all of that learning to have occurred, are we talking about my network and my data, and I go through a learning period of a few months where I put tons and tons of data through the engine to have it baseline my network? Or are we talking about aggregate shared across some anonymized set of Fortinet customers that build up the profile up in the cloud somewhere?
Both. So today, so I split into two areas. One is the security operations and one is the network operations. So from a security perspective today, we put it in our cloud. I think we have 100 billion events a day that come in, and we apply that machine learning. Now we're rolling out products which now we're going to take that, miniaturize it, and sit it inside a customer's environment. So it's very specific, because one of the issues with those cloud-based systems is you have to see it somewhere first, and that it's this first patient kind of rule. So we'll start applying that AI back into the customers, or machine learning and AI specifically in the customer's environment as we go forward. And that's even more important when you apply it to a network operations type system.
So I'm seeing it in my environment. I am sharing that information with Fortinet. There was a piece I missed there. So all of this munging and analysis is happening in the Fortinet cloud, and then some set of policies or baseline normative behavior comes out of that ML crunching and then gets sent down to my firewall for local enforcement, that kind of thing?
Yeah, so that's happening today. So we did that today. Yeah. But what I'm saying is if you've got a targeted attack that's going into a customer, we may not have the email path that's going in through phishing inside our cloud.
Because you haven't seen it yet.
Because they haven't seen it yet. So, but if I've got it on the customer premise and I'm sucking the email threat vector, the network, the endpoint into a mini on-premise AI system, then I see it instantly inside your environment.
Do I, as a customer, need to have some crazy amount of computing horsepower to have this system go forward?
Well, it depends on this. Obviously, it depends on the size. Yeah, I mean, large customers, huge. I mean, some customers have got 5,000 applications running and 200,000 people. So yeah, and 250 sites around the world. So yeah, so scale becomes an issue there. That's why you'll probably work on a more of a distributed model for those type of customers.
This is the future, though, John. This is an honest question. So Greg and Drew and I, we've been talking to a lot of folks who've been talking about AI and ML. And a lot of it just feels like pie in the sky. And it's like, we've been talking about it and the needle hasn't really moved for years and years, where we're still talking about it. We're still doing a little bit of training, but it's not like AI ops or that kind of thing is normal. It seems like more like a concept that we're always moving towards. Well, are we getting there? Like you mentioned, some of this technology from a Fortinet perspective is 12 to 18 months out. If we're getting there so that it's usable, what does it look like? What are we actually going to have that we can bank on with AI and ML?
Well, I think today you're getting the ML on the security side. You're getting some pretty good, fast analysis across the threat vectors, and we're getting that information back to you as quickly as possible. The AI piece of it is just problematic in just the scale and the size and the ability to look across all those threat vectors. So I think that's still coming. The machine learning's there. I think on the NetOps side, I think that's may even go a bit faster, even though it's a bit newer. But I think on the NetOps side, you've got a different problem. And I always get this, the internet's down, and people go, "Oh, well, the internet's down. Well, what's down? The internet's not down. The Wi-Fi's down, or the SD-WAN or the ISP's down, but the internet's not down. Or maybe the application's responding slowly." So the ability to apply AI ops across all those different areas is going to be a real key game changer, because you'll be able to identify exactly where the issue is. Hopefully you have some contingency where you can self-heal, but I think that's going to come very quickly on the NetOps side.
There's something unsaid that so far that is worth bringing up. The amount of data that's going through even a modest network is such that trying to analyze it by hand and digging through logs and stuff, we're way beyond that being possible. So from a certain point of view, AI and ML becoming functional is going to be necessary for appropriate security. Is that reasonable?
Well, again, I think it's security and operation. So it's great if you have good security, that's great. But if the network's down and the digital experience is broken, so I think it's across both. And you're right. It's gone well beyond the time where you can dig through things. Days later, you say, "Oh, I found it." No, it's too late.
One of the things that people told me about AI and networking is that it's actually a really good use case, because networking doesn't have a wide variety. It's not like trying to work out speech or, to understand vocal or how to read handwriting, because there's so much potential variety. In fact, the data that you collect from the network is actually highly structured and formatted, and sifting through the data isn't actually all that difficult. So that's not a criticism. What it's actually saying is it should raise people's confidence in it, because the actual process of extracting signal from the noise is actually much more reliable because the data source is structured.
Yeah, and I think that will be applied specifically to their network. So first of all, you've got a much more specific set of data. It's more structured, and so you can bring things out more quickly. I think with the security side, you may be missing a very vital piece. Maybe a botnet command and control is missing from the equation. You don't know what it is. Nothing fits together. So you're missing that. So I think you're right. I think it's the ability to. I sounded Australian then when I said that. That was an accidental Australian accent.
That does. It's taken me years. Just to be courteous, it has taken me many years not to drop into an American accent. Talking. Welcome to what it's like to be a podcast.
People ask me, they go, "Have you got? I like your accent." I go, "It's not an accent. It's English. That's what I speak."
That's correct. Yes.
Yeah. Anyway, I don't know what I was saying, but anyway, I think you're right. Security, AI ops, I think might go a lot faster than AI security ops.
Well, John, almost you convinced me that this AI ML stuff we've been talking about for so long is gonna become a thing. I almost feel like it's inevitable, and I don't have a choice but to believe that it's actually going to happen, and we're going to figure it out. If for no other reason than computing power has become so, relatively inexpensive, even though there's so much math and computing that is required to make all of this happen. Seems like we are indeed getting there. So. Thanks for trying to convince me, John, and we should check in 12 to 18 months and see what actually has come to life on the Fortinet side of things. In the meantime, John, is there anything that you want to share, resources from the Fortinet side that folks can take advantage of?
Yeah, so we've been investing heavily in what we call our Network Security Expert Program. There's 8 levels, 1 to 8. We just passed 500,000 certifications. I think it's one of the largest cybersecurity training programs. NSE 1 and 2 are open to the public. And in fact, we just included a security awareness training. People ask what's the low-hanging fruit around cybersecurity. It's people training. So we just included cybersecurity and security awareness training inside there. Our training is free to our partners. It always has been. As of this year, as of March, we actually made it free to our customers as well. So a big investment in training and education. The more you're educated on the systems, the better that you can use them. We also have major relationships with some of our big partners where we exchange information. Also, I think 300 universities around the world use some of the training facilities as well. So definitely go to Fortinet.com on our learning management center on there, and you can sign up for that stuff.
That's a good plug. I did not know you guys were so big into the training side of things. So NSE Institute, free training for Fortinet partners and customers. And all of that can be found at Fortinet.com/training. And then that link will be in the show notes up at packetpushers.net for this show. Just hop on the website, do a search for Fortinet, and it should be one of the things on the first page as it comes up there. Well, thanks, John, for coming on Heavy Networking, and thanks to Fortinet for sponsoring the show today, because if you're listening, it is through our sponsors that we get to keep researching information technology and bring you episodes that keep you up with the very latest for your professional career development. By the way, a little housekeeping, the Packet Pushers offer a free Slack group open to absolutely everyone in the community, even if you work for a vendor. Sign up at packetpushers.net/Slack and join nearly 1,500 IT professionals from around the world. And last but not least, remember that too much networking would never be enough.